Section 11.5, title is Angle Relationships in Circles. These are the objectives. Find the measures of angles formed by lines that intersect circles. The second one is use angle measures to solve problems. Let's go to the first theorem. This is what it says. This is if a tangent and a secant, it could also be a chord, intersect on a circle at the point of tangency. This is your tangent, this is the secant, this is the point of tangency, so this is where they intersect. Then the measure of the angle formed is half the measure of its intercepted arc. So whatever this is, this would be twice the arc, or if you want to create an equation, this is the formula that you have. Half of the arc is equal to this angle ABC. Let's look at the first example. Just find each measure. They want you to find the measurement of angle EFH. So we're going to be applying theorem 11.5.1. You should be able to see once you apply the theorem, this is the equation that we have. The measurement of angle EFH is equal to half of this arc FH. We substitute, we get the following. So the answer is measurement of EFH is 65 degrees. Part B, they want you to find the measurement of arc GF. Here's GF. Excuse me. So we're going to use that same theorem, 11.5.1. But before we continue, you should be able to see why. Well, this is the equation that we get when we apply the formula the theorem 11.5.1. Now you should be able to see why this is 58 degrees. This is a line, and these two angles have to be supplementary. And then at this point, all I'm going to do is substitute 58 for angle G. And at this point, I should be able to find the measurement of arc GF by multiplying both sides by 2, which is 116. And we're done with part B. Number 2, similar to the previous one, they want you to find the measurement of angle STU. Here's STU. We apply the same theorem. This is the equation that we get once we apply the theorem. This angle is equal to half this arc. Substitute. And at this point, you should be able to see why we get 83 degrees for the measurement of angle STU. Part B, they want you to find SR. I apply that same theorem. SRQ is given to us, which is 71 degrees. We substitute that in. Multiply both sides by 2. And that's how we get the measurement of SR. We're done with problem number 2. Next theorem, 11.5.2. It says if two secants or chords intersect in the interior of a circle, then the angle measure of each angle formed is half the sum of the measures of its intercepted arcs. So again, this angle here, angle 1, is equal to the sum of these two intercepted arcs, AD and CD, divided by 2 or multiplied by half. Okay. In the same manner, you should be able to see that we can very easily find angle 2 here. Since angle 1 and angle 2 are vertical, then whatever angle 1 was, angle 2 would also be that. And you should be able to find this angle as well. Once you know either 1 or 2, because angle 1 and this angle are supplementary in the same manner. Angle 2 and this angle are supplementary. Okay, let's move on to next example. In this case, they want you to find the measurement of angle AEB. AEB. So we're going to apply that theorem that you just saw, 1152. This is the equation that we get once we apply the theorem. The measurement of angle AEB is equal to the sum of these two arcs, AB and DC, multiplied by half or divided by 2. Once we substitute, we get 139 plus 113. This gives me 252. I multiply that by a half or divided by 2, and that's how we end up with 126. Problem number 4. Similar to the previous one, just a slight difference here. They want you to find the measurement of angle RNM. I'm sorry. So they want you to find this angle. In a little bit, we'll get to that. What we're going to do is we're going to focus on finding this angle here. Since they give me arc MQ and arc RP. If I apply theorem 1152, this is the equation that I get. The measurement of MNQ is equal to this arc plus this arc divided by 2 or multiplied by half. I substitute, and you should be able to see that this becomes measurement of angle MNQ is equal to 158. So this is 158. And at this point, you should be able to see that the measurement of RNM, which is the angle that they want me to find, plus this angle, M and Q, add up to 180. I'm going to substitute for M and Q, 158. And then at this point, I just saw for measurement of angle RNM. And that's how we end up with our answer of 22 degrees for measurement of angle RNM. Next theorem. This looks a little bit scary, but it's actually pretty easy. In this case, you have like this is the first case. You have a secant and a tangent. Second case, you have two tangents, and the third case, you have two secants. But pretty much is the same formula for all three cases. Notice that you have an exterior angle 1, 2, 3, and this is basically what the formula says. The relationship between angle 1 and the intercepted arcs. Change the color here. This arc and this arc. So this is what they're telling you. Forgive me for my drawing here, but this is what it says. The measurement of angle 1, this exterior angle, is equal to the large arc minus this small arc divided by 2 or multiplied by half. If you go to the next case, it's basically the same thing. The measurement of this exterior angle 2 is equal to this major arc here minus this minor arc divided by 2 or multiplied by half. Same thing for the last case for the two secants. This arc minus this arc divided by 2 is equal to this exterior angle 3. Problem number 5. They want you to find the value of x. So we're going to apply that theorem that you just saw. Notice that these are two secants. 1, 2 secants. So then, like I said, you apply theorem 1153. This is the this is what you have once you apply the theorem. X, which is the exterior angle, is equal to half the measurement of CG minus DF. I substitute. This is 87, it's right here. This is 7 degrees, right here. Do a little bit of math, and that's how we get 40 for X. So this angle here is equal to 40 degrees. Problem number 6. Same theorem, 1153. Once I set up my equation by applying the formula, this is what I get. Notice that in this case, they are giving you the exterior angle 25 degrees. And what you're looking for is this arc, X. So apply the theorem, the measurement of angle L is equal to half of this arc minus this arc. I substitute. I mean the exterior angle is 25, that's what we have, 25 here. Bring down the 1/2. Arc JN is 83 degrees, that's what you see here. Arc KM is X, which is what we're looking for. At this point, all we need to do is a little bit of algebra. If you multiply both sides by 2, you get rid of this fraction. And that's what I do, and that's how we end up with 50 on the left hand side, and then just 83 minus X on the right hand side. You should be able to follow, do a little bit of algebra here. You can take away 50, add X, and that's how you get X is equal to 33 degrees. And we're done with problem number 6. Next one. This is the last problem. So they want you to find the measurement of arc YZ, which is out here. This is what they're looking for. We cannot find this measurement in one step. We actually have to break it up into 2 steps. So step 1 is basically to find measurement of UY. So we're going to look for this first. And to find this is what I need to do. I'm going to have to use theorem 1152. Well, first of all, going back a little bit, you should be able to see why this is 67 degrees. This is a line, this is 113 degrees. So these 2 angles form a linear pair because it's a line. So they have to be supplementary. That's how we end up with 67 degrees. So, and at this point, going back, this is by applying theorem 1152. And it says that the measurement of X VY is equal to half this arc and the sum of this arc UY and the sum of this other arc WZ. You add these 2 arcs, WZ and WY, and you divide it by 2, and you get the measurement of this angle XVY. I substitute the information that I know. This is XVY, 67. Bring down the 1/2. This is what I'm looking for, arc UY. And I also know that this is 68 degrees. It was given to me. At this point, all I'm going to do is I want to solve for measurement of arc UY. So to get rid of this fraction, I'm going to multiply both sides by 2. You should be able to see that I get 134 equals the measurement of arc UY. To solve for UY, arc UY, take away 68 from 134, and that's how we get 66. Then we go to the second step. I'm going to find YZ, which is what the problem is asking me to do. To do that, I'm going to use the following. In this case now I'm applying theorem 1153. Again, this is theorem 1153. So then I have this tangent and I have this secant. Excuse me. This is my tangent. Here we go. This is my tangent. And this is my secant. There it is. So I'm going to be, like I said, I'm going to be applying 11.53. And this is what I get. The measurement of this exterior angle, which is x, is equal to 1/2 the arc YZ, which is what I'm looking for, minus this arc measurement of arc UY, which I found already. I substitute the information. Again, you see why this is 49. This I leave alone. I bring down the 1/2. I found out that this is 66 from step 1. At this point, just like on the previous step, out of one distraction, I multiply both sides by 2. This is how I get 98. And then at this point, solve for measurement of YZ by adding 66 to both sides. And this is my answer. The measurement of YZ is equal to 164 degrees. This is the end of this lesson.